What if I told you Earth is no longer keeping time correctly? Not your watch, not atomic clocks locked inside laboratories, not satellites circling above us, the planet itself. For billions of years, Earth has followed a precise rhythm, a hidden timing system driven by its rotation, its molten core, and its powerful magnetic field. This invisible clock decided when days ended, when seasons shifted, and when life could safely exist. But now, scientists are sounding a quiet, uncomfortable warning. That rhythm is slipping. Earth's rotation is behaving strangely. The magnetic field is drifting faster than ever recorded. Deep inside the planet, something is no longer moving the way it should. And here's the part no one expected. 2026 could be the tipping point. Across the globe, warning signs are stacking up. Volcanoes that were considered dormant are waking up. Earthquakes are clustering in unusual patterns. The planet's magnetic shield, our protection from deadly solar radiation, is weakening in key regions. Even more disturbing, scientists are detecting strange signals coming from deep beneath Earth's surface, places humans can never reach. Signals that suggest the core of the planet may be out of sync. This isn't science fiction. This isn't a movie plot. This is real data coming from satellites, seismic stations, and decades of measurements. And the most unsettling truth? They don't fully know how to stop it. Earth's inner clock isn't something humans can reset. We can't slow it down. We can't stabilize it. We can only watch and prepare. Because when the timing of a planet changes, even slightly, everything built on top of that timing begins to crack. Power grids, GPS systems, global communication, modern civilization itself. What you're about to hear isn't meant to scare you, it's meant to wake you up, because the next few years may redefine how stable our world really is, and if Earth's inner clock truly is off, time may already be running out. Stay till the end, because understanding this now could change how you see the future forever. Earth isn't just a silent rock drifting through space. It's a living, dynamic system, one that moves, pulses, and keeps time. Deep beneath the oceans, continents, and cities you see every day, the planet operates on an internal rhythm. Scientists don't usually call it a clock in public discussions, but behind the scenes, that's exactly how they treat it. Because Earth runs on timing. This timing controls how long a day lasts, how stable the climate remains, how protected life is from deadly space radiation, and it all starts with three powerful systems working together. First, Earth's rotation. The planet spins at a carefully balanced speed, giving us 24-hour days and stable seasons. Even tiny changes in rotation, fractions of a second, can ripple through weather systems, ocean currents, and global technology. Second, the movement of molten iron deep in Earth's core. Nearly 3,000 miles beneath your feet lies a swirling ocean of liquid metal. This motion isn't random. It follows patterns, cycles, and timing that scientists have tracked for decades. This movement generates heat, pressure, and energy that shape everything from tectonic activity to volcanic eruptions. Third, Earth's magnetic heartbeat. This is the invisible shield that surrounds the planet, blocking harmful solar radiation and cosmic particles. Without it, life as we know it would not survive. This magnetic field isn't static. It pulses, shifts, and adjusts based on the movement of the core. Together, these three systems act like interconnected gears in a massive planetary machine. This is Earth's inner clock. For thousands of years, long before modern civilization, this clock stayed relatively stable. Yes, Earth changed slowly over time. Yes, there were ice ages and natural cycles, but the rhythm itself remained predictable. Civilizations rose because of it. Agriculture depended on it. Navigation, seasons, and even human biology evolved around it. But now, that rhythm is slipping. Scientists are observing changes that don't fit historical patterns. Earth's rotation is no longer consistent. It speeds up, slows down, and corrects itself unpredictably. The molten core appears to be shifting its behavior, and the magnetic field is weakening and drifting at rates never recorded before. These systems are still functioning, but they're no longer perfectly synchronized. Imagine a clock where the second hand moves slightly off-beat. At first it seems harmless, but over time minutes drift. hours become inaccurate, and eventually the entire system fails to tell the truth. That's the concern scientists are facing now. Earth's inner clock hasn't stopped, but it may be losing alignment, and when a planetary system that controls earthquakes, volcanoes, and radiation shielding loses alignment, the consequences don't stay underground, they rise to the surface. In the last decade, something unusual caught scientists off guard. Not one event, not one anomaly, but a pattern. Across independent research centers, observatories, and satellite systems, researchers began noticing the same unsettling signals. Earth's rotation is no longer behaving predictably. Some days are slightly shorter than expected. Other days the planet slows down, then corrects itself again. These changes are tiny, measured in milliseconds, but on a planetary scale, they are massive. At the same time, another red flag appeared. Magnetic north is drifting faster than ever recorded in human history. For centuries, the magnetic poles moved slowly, so slowly that maps barely needed updates. Now, navigation systems, aircraft routes, and military instruments require constant recalibration. The magnetic field isn't just moving, it's unstable. Then came the third warning sign. Seismic activity began behaving differently. Earthquakes aren't just increasing in certain regions, they're clustering. Multiple quakes in places that were once considered low risk. Strange pauses followed by sudden releases of energy. This pattern doesn't match normal tectonic behavior, and that's when scientists realize something critical. This isn't random. All these changes point to the same place. Deep below your feet, nearly 3,000 miles underground, in a region humans will never reach, Earth's molten core. The core is the engine of the planet. It generates heat. It drives the magnetic field. It influences tectonic pressure across the entire globe. For decades, scientists believed its motion followed stable cycles, but new data suggests otherwise. Measurements now indicate that parts of the molten core are slowing down, shifting direction, or moving out of sync with the mantle above it. Imagine the engine of a car running at uneven speeds. The wheels still turn, but vibrations travel through the entire vehicle. That's what's happening to Earth. When the core's rhythm changes, the magnetic field weakens and drifts, pressure builds unevenly in the mantle. Fault lines experience irregular stress, and everything above, oceans, continents, cities, feels the effect. This is why scientists are no longer asking if something is happening. They're asking how far it will go, because once the core's rhythm changes, the planet doesn't correct itself quickly. It responds slowly, powerfully, and sometimes violently. And that realization has made one thing clear. Earth's inner systems are no longer perfectly aligned, and when the foundation shifts, the surface always follows. Here's the shocking part. Recent studies suggest that Earth's inner core may have slowed down, paused, or even slightly reversed its rotation relative to the rest of the planet. Read that again. The very engine of Earth, the part responsible for stability, protection, and planetary balance, is losing synchronization. For decades, scientists assumed the inner core rotated steadily, like a perfectly timed motor. But new seismic data tells a different story. Waves traveling through Earth's interior are no longer behaving the way models predicted. They arrive early, they arrive late. Sometimes they don't align at all. This isn't speculation. It's being measured through global seismic networks, comparing signals across thousands of earthquakes. And the conclusion is unsettling. The core's rhythm is changing. When the core changes speed, even slightly, the effects don't stay deep underground. First, pressure shifts. The molten metal inside Earth redistributes energy unevenly, creating new stress points throughout the mantle. Second, mantle tension increases. The semi-solid layer above the core begins to stretch and compress in unfamiliar ways. This tension has nowhere to go, except upward. Third, fault lines destabilize. Plates that once held steady are now under irregular stress, sometimes locked too tightly, sometimes slipping too easily. This chain reaction explains something scientists couldn't figure out before: why volcanoes are waking up simultaneously across different regions. Eruptions aren't isolated anymore. They're appearing in clusters, as if responding to a shared trigger. Why tsunami risk zones are expanding. Undersea quakes are shifting in depth and intensity, increasing the chance of sudden ocean displacement. Why Earth's magnetic field is weakening. The magnetic shield depends on the smooth flow of molten iron. When that flow becomes erratic, protection weakens, especially in vulnerable regions. This is no longer a theory, this is no longer a what-if. This is measured data. Earth's core hasn't stopped, but it's no longer moving in perfect harmony with the rest of the planet. Imagine a massive orchestra where the conductor suddenly changes tempo. The music continues, but it becomes unstable, unpredictable, and strained. That's where Earth is right now. The core is desyncing, and when the heart of a planet loses rhythm, the surface always feels it next. So why is everyone quietly whispering about 2026? Why that year? Why not now, or decades from now? Because for the first time in modern history, multiple powerful planetary cycles are converging at the same moment, and when that happens, Earth doesn't gently adjust, it destabilizes. The first cycle is the solar maximum peak. Every 11 years, the Sun enters a phase of extreme activity. Violent solar flares, radiation bursts, and magnetic storms aim directly at Earth. During solar maximum, the Sun doesn't just shine brighter, it becomes aggressive, and 2026 sits right in that peak window. The second cycle is Earth's magnetic field fluctuation. Right now, the magnetic shield protecting our planet is weakening and shifting faster than scientists ever expected. Weak magnetic zones, especially over the Atlantic and polar regions, are expanding. During strong solar activity, a weak magnetic field is dangerous. Radiation penetrates deeper, satellites become vulnerable, power grids are exposed. Then comes the third and most alarming factor, the core oscillation phase. As you've learned, Earth's core isn't moving smoothly anymore. It's wobbling, slowing, and adjusting in unfamiliar patterns. These oscillations don't happen randomly, they follow long cycles, and 2026 to 2028 is when models show maximum instability. Now here's the terrifying part. When these three cycles align, a violent sun, a weakened magnetic shield, an unstable planetary core, Earth becomes extremely sensitive to stress. That's why scientists fear the years 2026 through 2028 could bring cascading disruptions. Massive earthquakes, triggered by uneven mantle pressure, power grid disruptions, caused by solar storms, overwhelming infrastructure satellite failures, knocking out GPS, internet routing, and weather monitoring navigation system chaos, affecting aviation, shipping, and military systems worldwide. And yes, timekeeping itself could be affected. Modern civilization depends on Earth's rotation being precise. Atomic clocks must constantly adjust for changes in day length. If Earth's spin becomes more erratic, those corrections increase. Milliseconds matter in financial markets, in military systems, in global communications. This isn't about one disaster, it's about systemic stress, many systems failing at once. That's why scientists aren't panicking publicly, they're preparing quietly. Because when planetary cycles align like this, history shows one thing clearly: Earth doesn't negotiate, it responds. Perfect timing, every second of your daily life, navigation, banking, communication, defense, depends on Earth behaving like a reliable clock. At the center of this system are GPS satellites. They don't just tell you where you are, they rely on ultra-precise timing signals synced with Earth's rotation. A delay of even 1 millisecond can translate into location errors of hundreds of feet. Then there's internet timing. Data doesn't just travel, it arrives in carefully synchronized packets. Servers across the world rely on timestamps to function correctly. If those timestamps drift, systems fall out of sync. Next comes financial transaction clocks. Global markets process trillions of dollars every day using time-based verification. Trades are validated in microseconds. A tiny mismatch in timing can cause failed transactions, market glitches, flash crashes, and finally, military systems. Missile defense, radar tracking, encrypted communications, and satellite surveillance all depend on precise planetary timing. There is no margin for error. All of these systems assume one thing: Earth will keep time accurately. But what happens if it doesn't? If Earth's rotation shifts, even slightly, atomic clocks must constantly correct for the difference. These adjustments are already increasing. Scientists call them leap-second corrections, and they're becoming more frequent. Now imagine those corrections accelerating. GPS accuracy degrades. Communication networks fall out of sync. Financial systems experience unexplained anomalies. Not total collapse, but enough instability to cause serious damage. This is why governments aren't talking loudly about Earth's shifting clock. Not because they're hiding something, but because panic doesn't fix infrastructure. Instead, they're preparing, hardening power grids against solar storms, updating satellite timing protocols, stress testing financial systems, reinforcing communication redundancy. Behind closed doors, agencies know the truth. Technology evolved assuming a stable planet. But the planet may be entering an unstable phase, and technology doesn't adapt overnight. That's the real risk, not a single catastrophic event, but a slow breakdown of systems we trust blindly. This isn't fear, this is physics meeting reality. Because when Earth changes its rhythm, no technology on the surface is truly independent from it. As advanced as our technology has become, there are limits we cannot cross. We've sent probes to the edges of the solar system. We've split atoms. We've mapped distant galaxies. But the heart of our own planet, it remains untouchable. We can observe what's happening. Using seismic waves, satellites, and decades of data, scientists can listen to Earth's interior like doctors using a stethoscope. They can detect changes in motion, pressure, and rhythm deep below the surface. We can model it. Supercomputers simulate how the core, mantle, and crust interact. These models help scientists predict possible outcomes, where stress might build, where systems might weaken, and when instability could peak. And we can warn. Early alerts, risk assessments, infrastructure planning, public safety strategies. But that's where our power ends. We cannot stop molten iron moving at thousands of degrees, stabilize magnetic fields that span the entire planet, slow tectonic plates driven by forces billions of years old. Earth doesn't run on software. It doesn't respond to commands. It doesn't negotiate. Earth operates on forces far beyond technology. The core generates energy on a scale humans can't influence without catastrophic consequences. Any attempt to interfere would likely do more harm than good. That's why scientists don't talk about fixing the problem. They talk about adapting. We may only be able to adapt. That doesn't mean giving up. It means shifting perspective, strengthening infrastructure, designing systems that tolerate instability, preparing societies for disruption instead of assuming permanence. This realization is deeply human. For centuries, we believed progress meant control over nature, time, and risk. But moments like this remind us that we are still guests on this planet. The Earth doesn't belong to us, we belong to it. And when its internal rhythm changes, the smartest response isn't arrogance, it's humility. Adaptation isn't weakness, it's survival. Because the future won't belong to those who try to dominate Earth. It will belong to those who learn how to live with its changes. Let's be clear about one thing first. This does not mean the world ends tomorrow. There is no countdown clock to extinction, no single day where everything suddenly collapses. But it does mean the world is becoming less predictable. And unpredictability is what challenges modern life the most. As Earth's internal systems lose perfect alignment, the effects show up on the surface in subtle but powerful ways. More extreme weather, storms grow stronger, heat waves last longer, cold snaps arrive out of season. These events don't follow the patterns we grew up trusting. When Earth's energy balance shifts, the atmosphere responds first. Infrastructure stress, roads, bridges, power grids, and pipelines were built for a stable planet. As ground pressure changes and weather intensifies, that infrastructure faces strain it was never designed to handle. Small failures become big ones faster than expected. Unpredictable natural events, earthquakes in unexpected regions, volcanic activity in places once considered low risk, sudden floods, landslides, or sinkholes with little warning. The danger isn't constant, it's irregular, and irregular threats are the hardest to prepare for. So what does this mean for you, personally? It means location matters more than ever. The The safest regions tend to be geologically stable zones with minimal seismic history areas, away from major fault lines, subduction zones, and volcanic chains, places with strong infrastructure, emergency planning, and resilient energy systems. This doesn't mean people need to panic or relocate overnight. It means people need to pay attention, understand the risks in your region, know how your local systems respond to stress. Have basic preparedness, not fear, but readiness, because awareness changes outcomes. When you understand what's happening, you make better decisions, you react faster, you recover sooner. Ignoring these changes doesn't protect you, it leaves you unprepared. History shows that civilizations don't fall because of one disaster. They fall because they ignore warnings, underestimate change, and assume stability will always return. Knowledge is not fear. Awareness is power, and in a world where Earth itself is becoming less predictable, being informed may be the most important survival tool we have. Earth has gone through cycles before, but never with 8 billion people, global digital dependence, fragile systems. If Earth's inner clock is truly off, then humanity is entering a new era, not of fear, but of adaptation. If this information surprised you, if it made you think, if it made you uneasy, comment time below. Let me know you're aware. Like this video, subscribe for real science, real warnings, real truth. Because when Earth changes its rhythm, time really does start running out.